When I was somewhat younger, working on my famous Dresden book, I asked an old war buddy named Bernard V. O'Hare if I could come to see him. He was a district attorney in Pennsylvania. I was a writer on Cape Cod. We had been privates in the war, infantry scouts. We had never expected to make any money after the war, but we were doing quite well. I had the Bell Telephone Company find him for me. They were pleased that way, wonderful that way. I have this disease late at night sometimes, involving alcohol and the telephone.
This chapter describes another important recursive strategy called backtracking. A backtracking algorithm tries to construct a solution to a computational problem incrementally, one small piece at a time. Whenever the algorithm needs to decide between multiple alternatives to the next component of the solution, it recursively evaluates every alternative and then chooses the best one. The prototypical backtracking problem is the classical n-queens problem, first proposed by German chess enthusiast Max Bessel in 1848 for the standard 8x8 board, and by Francis Joseph Eustache Lignet in 1869 for the more general n-by-n board. The problem is to place n queens on an n-by-n chessboard so that no two queens are attacking each other. For readers not familiar with the rules of chess, this means that no two queens are in the same row, same column, or the same diagonal.
This gives us our first greedy algorithm. To minimize the total expected cost of accessing the files, we put the file that is cheapest to access first, and then recursively write everything else. No backtracking, no dynamic programming, just make the best local choice and blindly plow ahead.
Now, what order should store the files if we want to minimize the total cost? The question is similar in spirit to the optimal binary search tree problem, but the target data structure and the cost function are both different, so the algorithm must be different too.
A variable declared to be of type float can be used for storing values containing decimal places. A floating point number constant is distinguished by the presence of a decimal point. You can omit digits before the decimal point or digits after the decimal point, but obviously you can't omit both.